Okay, now that we have an implementation plan laid out for this section, let's go ahead and get busy. So the first thing we're going to do is start out over here inside of Visual Studio Express and get some constants defined.
All right, so we're already in the game class, and all I'm going to do is track back up to the beginning. Right before textures, let me jot down a comment for player fields. So we'll say player, and then we need our two constants. These are both going to be floats, and they're going to be player speed slow and player speed fast. Player speed slow, and that is going to be set to a value of 5. Then we're going to have the constant float for the player speed fast. So player speed fast is going to be set to 10. Let me put floating after both of those. Alright, those are the player speeds. And of course we want the player field itself. So this is going to be a private field of type player, which I'm going to call player. So this is our always existing reference to the player itself. Alright, now we can jump down to load graphics content and get the player itself created. Keep in mind that we still have this player texture reference that we created when testing the actor. And this is now going to go into its real use, and that is to create the player. So, scrolling down here, I believe we're done with all of this test code where we had made a temporary actor. So I'm going to delete all of that and instead create a player. And I'm going to do that by storing it in the player field. So the player field, as a matter of fact, it could even be this dot player equals a new player. Player is going to take in a texture 2D, so we're going to feed it the player texture. And that will create the player.
Okay.
Alright, now we need to move down to update. And then, as we're looking through actors, we need to see if the current actor is a player. So I've scrolled down to update. Now we're inside of the game state switch, and then inside of playing, here's our loop for finding and iterating through all actors. We've even got the actors copied out into a local variable. So, in order to do this check, we need to do pretty much the same thing as was written on the whiteboard. Check and see if that actor is a player. So if actor is player, then we know that the current actor is indeed the player, and it needs to be affected by the controller. So inside here, the first thing we're going to do is define a vector2 variable so we can capture the direction that the left thumbstick is pointing. So I'm going to make a vector2, which I'm going to call direction, and we'll set that variable to a new vector2. We're going to take in the x and y. Now you may be wondering why I'm making a new vector2 instead of just using the thumbstick, and that's because I want to reverse the thumbstick. We had shown back in the input lesson that by default if you translate the movement into screen space it'll be inverted. So I'm doing my own vector so that I can invert y. I'm not, however, going to invert x, so x is simply going to be gamepad state dot thumbsticks dot left dot x. And then let me jump down a line so that this fits on screen better, and jump over a little where we've got y. Y is going to be inverted, so y is going to be negative gamepad state dot thumbsticks dot left dot y. So we have a new vector2 created based on the thumbsticks, except with a reversed y-axis. Alright, the next thing we want to do is do a check to see if we need to normalize that. That means establish our digital style of movement. What I'm going to do here is first make sure that there is some value to normalize, because if we don't, if we have a length of 0 and we normalize that, we get a result of not a number. And then we have no place we can draw the player and it disappears.
Right.
So we want to put in a check. So say if that direction variable's length is greater than 0, then we can normalize it. So then we take direction and tell it to normalize. Otherwise, we want to make sure that if there was some value that some value other than what we could normalize, so some value other than 1, we want to make sure that we hard set it to 0. That means if we ever start using our own custom threshold here, we don't allow for some movement up until that point. So that means we either had some valid movement, which we normalized, or we're going to set the direction to 0. So direction equals vector2 dot 0.
And as a quick reminder, we have talked about this in greater detail back in the input section of videos.
Right, that's why I'm just kind of glazing over it here. Alright, moving on. Next, we can take a look at doing the button input. I'm actually kind of deciding here if we should test, because I mean we should be able to, thinking about it. Let me do a test, though I need to set this. We've got a direction established, so let me impart this direction into the actor itself.
Exactly.
So I'm going to jump down a few lines and put this in before I get the rest of the movement code. That would be actor.position needs to be incremented by this new direction. So, and then we'll get into a more advanced version of that here in a second. So let's see.
Now the numbers are going to be pretty small. I mean, well, we'll see movement though. I was going to say, do you want to go ahead and multiply it by one of the...
I'm going to show it being very small,
okay.
And then we'll take a look at what we need to do. So there's the player still starting in the upper left-hand corner of the screen, but if I'm moving it, you can see it moves rather slowly. Though we do have the digital style of movement established, where we either have no movement or movement at a continuous speed. And then we have all of our direction. This is, of course, very slow, and it's slow because we're not taking into account the actual speed that we want. Direction should always have an overall length of 1.
Right.
And we know we wanted speeds like 5 and 10, but since it is 1, that gives a convenient value to multiply. So we could multiply against something like player speed slow, and then we get the actual player speed we're looking for. But that actually leads us into the next thing we need to calculate, and that's the fact that there are 2 speeds for the enemy, fast and slow, depending on whether or not the B button is held. So let's finish that off before we move on. Let's instead put an if statement around this that says if the gamepad state dot buttons dot b is equal to button state dot pressed, then we know we want the fast speed. So let me tab this over and change it to player speed fast. Otherwise, we want the slow speed. So I'm going to steal that line of position incrementing, paste it, and change it to back to player speed slow. So B button equals fast, otherwise slow. So now if we run, we can see we have normal speed, or hitting B allows us to go much faster. So simple as that. Alright, now, actually I should have left the game up because that leads us into the next point, and that is screen bounce checking.
Yeah, go ahead and run.
If I bring the game back up, we can see that the player is allowed to move directly off the screen. So I could move around and then kind of screen warp in from the top. And this needs to be corrected. We don't want the player to be able to leave the screen. That means we need to do some bounds checking to see if its current position is in fact on screen. So moving down, what I'm going to do here, since I want to do the checks of X and Y individually, since it makes setting each component more simplistic, is I'm actually going to pull the position out of player and store it as a local variable. That makes it easier to work with, and then I'll save it back in. So what I'll do is I'll make a vector2, which I'm going to call player position. And we'll set that vector to be equal to actor.position. Then we can do some checks. The first check will be if have we gone off the left side of the screen. And that would be represented as if player position dot x is less than. Now we want to take the, we of course can't use 0 because that'll center us on the side of the screen. We actually need to take our origin into account so that we go all the way off screen. Meaning if player.position is less than player.origin, or excuse me, not player position, rather actor dot origin dot x. So basically if the actor has hit the very left side of the screen.
Okay.
If that's the case, then it needs to be reset so that we don't, so that we snap back on screen, because less than means we have gone a little bit off screen.
Right.
So we need to perform some kind of snap to put us back on screen. And we can do that with player position dot x being set to this origin. And there we go. So we can do another check. If we didn't go off the left side of the screen, maybe we went off the right. So I'll do an else if player position dot x is greater than screen width minus the actor's origin in x. And if that's the case, then we need to set it to the screen width minus the actor's origin, or player position dot x equals this value, screen width minus actor origin dot x. And that takes care of the x bounds checking. I'm going to test that before I move on to y, because I'm basically going to copy this block of code. Now we do need to remember to take this position and save that back into the actor. So we would take the actor then and set its position now to the possibly adjusted player position. And already looking at the actor, it's now moved to the right a little bit. It's not perfectly centered. Of course, Y can still go off screen, but X is now locked. I can't move the player off the screen. Now for the right side of the screen, same thing. It feels as though the player simply collides with the side of the screen and stops moving.
Excellent.
And that's the desired effect. So all that's left is to use this code to check in the y-axis. And to do that, I'll just copy the block, paste the block, and adjust it for y. So in all of these cases, player position y, origin y, same for the correction line. Then once again, position y against the screen height, and origins y, origin and y, player position and y, once again, versus screen height. So now, the player is completely on screen at the top left corner of the screen, cannot go off the top, left, bottom, or right. So now we are constrained to the screen.
Okay.
So looking at this, there is just one thing left I want to address, and that is this was just one of the checks that are going to happen inside of this loop, meaning that there's a possibility that actor could be something other than a player, which means we would get outside of this if statement, and then more possible checks would occur.
There's no need to continue checking things.
Right. Now, if we had gotten into this if statement, actor was a player, there's no reason to check and see if it's anything else. So I'm going to put in a continue, so that we simply ignore any further code and just go on with the next iteration of this loop.
Precisely.
So if this was an actor, skip any other possibilities and just move on to the next actor.
Okay. Well, fantastic. Is there anything else you want to add? Because this is what we set out to accomplish for this part.
Nothing comes to mind, really. It was just a matter of defining the player, receiving input, and then balance checking to keep the player on screen.
Okay. Well, that is going to wrap up part 4 of Precision. Thanks a lot.